Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, welcome everyone. Thanks for joining us on Happy Path Programming. Today we have with us Sabine, who I really just met you on Twitter recently because everyone is talking about OCaml. So I was like, hey, let's have Sabine on and learn about OCaml. And Bruce and I have, over the last week, written some code in OCaml and explored it a bit. And so excited to have you on. Welcome, Sabine.
Well, thank you for having me. I'm very happy to be here. And yes, actually, I only became an OCaml org maintainer last year.
Okay.
In September, incidentally. So pretty much 1 year of OCaml for me.
Nice. So what is your day job? Do you work on OCaml, use OCaml?
Yes,
what do you do normally?
In fact, my day job is OCaml.
Oh, nice.
And in fact, it's OCaml org.
Okay. What is OCaml org?
That's the official OCaml website.
Okay.
Which is written in OCaml.
Nice. Awesome.
Which is kind of the usual flex that every programming language has to go through, having their own website or some infrastructure written in itself.
Yeah.
The first step after you have your own compiler written in the language.
Yeah. How is it that you get to work on OCaml stuff as your day job?
Luck. To be honest, sheer luck and being in the right place at the right time. Probably also credentials.
Okay. So is there a company behind OCaml that's funding that work, or how does that work?
So there's multiple companies in the OCaml ecosystem that are funding OCaml development. Some of OCaml development is funded also by research grants, but that's more on the compiler side. On the tooling side, there's a handful of companies like Tarides, OCaml Pro, and a few others who contribute to this development. And I work at Tarides, who is very active in improving the tooling at the moment.
Okay.
And also the stewards of the OCaml org website at the moment.
Mm-hmm. Nice. And so you get to just improve the experience of OCaml and learning of OCaml as your day job.
Yes, I do. And it's kind of a pretty demanding position in the sense that you are in this open source universe and you know that a lot of people will be very excited to do this job and they have high expectations on you in a good way. I mean, because you really want to do a good job for them.
Yeah. Positive pressure.
Positive.
Yeah.
So how did you get into OCaml? What's your story?
This is a longer story.
I'd love to hear it.
So that starts with studying computer science in the early 2000s.
And where
my
was
first language in Saarbrücken, Germany.
Okay.
So university that was more heavy on theory. And one of the universities that would start out in first year computer science by teaching standard ML. So I don't know if you have heard of or used standard ML, but this is basically some kind of OCaml light.
Okay.
So
what's the connection between OCaml and standard ML? Because I've heard the terminology like, oh, Scala is in the family of ML languages or whatever. What does that actually mean to be like, what is the ML family?
So there's a very rich academic tradition behind this that goes back to the type systems explored by Hindley and Milner. And they came up with the type lambda calculus. I'm actually not even sure anymore. I forgot so much. I learned so much and I forgot so much. But there's always comes that back to Hindley Milner. And if you want to go down this rabbit hole, it's a deep rabbit hole. So you can learn a lot about type lambda calculus, about statically typed functional programming languages, where you have type systems that are very, very expressive, that allow you to model what your data looks like in a very fine-grained fashion, where you can describe units of data in such a way that you have these discriminated unions, these sum types. Sometimes they're called variant types. So in OCaml, they're called variant types, where you say that a value of a given data type is, for example, either a success value, has a certain shape, certain fields, or an error value has other fields. And you can model anything you want this way: trees, graphs, JSON data. So from a practical perspective, you're mostly modeling these kinds of more things that you see in the wild.
Uh-huh. So the Hindley-Milner, am I saying that right?
Type system.
So the this is like the type system calculus stuff this was decades and decades ago. And then
Yes.
languages started, like more kind of academic languages started to try to implement those ideas. Is that the right way to say that?
Yeah, that's right, actually. So there were multiple languages that developed, mostly in an academic setting, because they were wonderful research projects. And one of these languages is OCaml, that was created by Xavier Leroy in the 90s.
It was in the 90s, yeah.
Okay.
That's what
So,
I found. But
it goes,
ML itself, when that was in the 60s, wasn't it?
yes, that's much older. So the general ideas underlying OCaml are much older even.
So OCaml became one of the ML family languages that took these ideas and tried to build a real language around them. Is that the accurate? Yeah.
Yeah, that's pretty accurate. I
And
would
the
say
O
so.
is for object, right?
Yes. So this is objective camel. So there was a language was earlier called camel, and it became objective camel. And it's actually quite fun to look at the old website of that. So I really like looking at stuff on the Internet Archive, the Wayback Machine, looking at how things looked like back in the 90s.
Yeah.
I mean, I was there for some of it, but I was not there for OCaml. So
do some archaeological digs into the past to see how we got to where we are today. That is always fun.
So it sounds like your experience was you went to this more theoretical computer science program, and then when you saw OCaml, it was just
no, not at all. So actually, it was much weirder. I happened to stick around in academia until after I had a PhD. In formal verification. So I kind of just swam along. I didn't know what to do. So I didn't really even have the passion that you should usually have for a PhD. But it's one day I just decided, like, okay, I'm not going to stay in academia. It's not going to work for me. I don't care enough about this whole institutional model.
But this was after you got your PhD?
This was after I got my PhD.
Okay, so you were starting to teach and things?
I should have been starting to teach. I was basically poised to go to Carnegie Mellon University on a research grant. So I successfully applied for that, but I couldn't see myself going there with a toddler and with the US standards of work ethics.
Yeah. So were you in your PhD program, or before that, were you using OCaml and so no formal verification?
There was pretty much no OCaml for me until last year, and this makes it even more ironic considering how many people out there are really into OCaml and basically dying to get this job.
But
on the other hand, what I did in the meantime, after I left my PhD, that prepared me uniquely for this kind of opportunity.
Right. I would think, because like for me, my first, functional language was quite a struggle at the beginning. But then the more I saw of it and the more I understood, then like you pick up a language and you go, oh yeah, I see what you're doing here and here and here and here. And you can actually have a pretty deep understanding fairly quickly. So I would imagine with your background, when you did start picking up OCaml, it was like, a
lot of familiarity.
Yeah. Yes. So when you've used standard ML and when you have done a few proofs in Isabelle Holl, which is a proof checker, so automated.
I've never even heard of that
prover.
one. Isabelle, what was it? Isabelle
So it's basically, at the time back then, it was the other one next to Coq.
Okay.
And Coq is more on the OCaml side. And Isabelle was more on the standard ML side. So obviously that gives you some intuition for how to use this and how to write pure functions, how to write recursive functions, how to do the FP things.
Yeah.
Okay.
So you were doing this at least in the PhD side with Isabelle. And then were you using other ML languages before you got into OCaml, or was it mostly
Yes, in fact, I did.
Yeah.
In fact, on my journey, I passed OCaml by because it looked to have such a small community, because it looked to be so secluded, so hard to get into in terms of available ecosystem, in terms of being able to reach people, talk to people back then. But that was in 2015-16 when I looked at OCaml for a moment and passed it by.
Where'd you go instead?
Haskell.
Okay.
Okay.
So the journey to Haskell. So you were doing Haskell for a while.
So it sounds like your world is basically heavily functional languages.
Not really, because the first thing I did after I threw away academia and said no more of this was that I wanted to build a website for people that saw in Python Django. Of all the things. And I learned a lot from that, the good and the bad. The good about me and the bad about me. Because when you don't write tests in Python, you are not going to have a good time.
Right.
And I did not want to write tests.
And were you doing this before Python had type annotations?
Yes, type annotations in Python were very, very alpha, not usable actually at this point.
Yeah.
And I think
it's kind of wild to go from like formal verification ML stuff to like the total wild west of Python dynamic typing.
Yes.
It's like hopping to the other end of the universe.
Yes, right. So it was also hopping from the one side, from the academic universe to the universe of, okay, we are going to do this solo bootstrapper thing where we build something and have a lot of people use it and pay us for it. Yes, it's not that simple. You can be naive even when you have a PhD, you know?
Yeah. So as part of your thinking, I don't need to write tests because, why would I write tests? I write types.
Right. But this is not true either. So you should still test some things. But there's a lot of things you don't need to test when you have types.
Yeah. So you did some work in Python and then passed by OCaml and then went to Haskell. What was your experience like in Haskell?
Well, in Haskell, you have this kind of steep learning curve in terms of getting through this wall of seeing how do I deal with these different monads? How do I make it compile and run? So I know what I want to do. I have a tutorial in front of me, and then I have some not immediately obvious type errors. So I read a lot of monad tutorials.
I'm sure that was helpful.
Well, actually, it was at some point. Like when you do it often enough, it works. Like you just have to be really stubborn and you have to want it. Or you have to have someone who shows you what to do. I didn't. But that was cool because you can make up a lot by being just stubborn and keep trying, doing, and reading different things.
That's generally my strategy. Is I just go. I know it was just from my physics background, which I didn't understand very well at the time, but I knew that if I just kept flinging myself at the problem, eventually something would give. And so that's the strategy I've used for everything else.
Yeah,
it's like
So the strategy is read many things about monads. And this is at least my strategy, still not understand them. And then as soon as I did understand them, I'm going to write my own monad tutorial, which I did.
Oh,
yeah.
I never saw
Yeah,
that.
it's on my blog.
Oh, that's cool.
Yeah.
I didn't.
And of course, that just adds to the corpus of monad tutorials that ultimately aren't helpful or something. But so okay, Haskell and some beating your head against monads. Any other part to that journey before you get to OCaml?
Well, not so much, I think. So, well, there was also Elm.
You did some
So
Elm.
actually, I did
Nice.
Elm before Haskell.
Yeah.
Because I wanted to build great user experience. I wanted to build something interactive, something that Django couldn't, I believe Django couldn't do. Or at least Django plus my mess of Frankensteinish jQuery and publicly available libraries couldn't do. Nowadays, I think that's a much more nuanced thing.
Yeah. For me, Elm was, I haven't done any Haskell, but for me, Elm, when I did Elm, I'd been doing some functional programming, but it hadn't used the Haskell style syntax, and I really liked Elm, and I would much rather build a web app in Elm than jQuery and Python.
Yes, for sure. Just the way I wanted to build the web app, it was not very suitable for Elm. So I wanted to do this single page app thing where you had the bookmarkable URLs, where you had the proper URL parsing, basically. It worked, but it got pretty slow in compiling because I just wanted to do everything. And this is not how you use Elm. So Elm is more like you make smaller components. You make individual pages and then have the interactivity for them implemented in Elm. That works very well, and that's incidentally also the use case that No Red Ink had for Elm, that they have lots of small components, and Elm is wonderful for that, and still is, despite people declaring it dead. I don't think it's dead. It's still very solid.
It's not great for single-page applications?
Yeah, so for single-page applications, you have to deal with a lot of these data loading. You get very, very huge case switches depending on which page are you on. If you do the real single-page application,
kind of the router, the like client-side router,
right?
Becomes pretty
The
complicated.
router, the data loading, and all that. Other than that, it works actually quite fine.
But it does seem like Elm is probably a great path to Haskell. Like if you want to learn Haskell, Elm might be a good place to start. Yeah. Oh, interesting. So maybe my Elm experience helped me with the OCaml that we've been exploring.
I would say, I mean, certainly some of the things like, initially the syntax, if you've never seen that alternative syntax without the parentheses and without the commas for function calls, that's a little jarring. But once you're used to it,
the like curried function style.
Yeah, that's but at first it's like, this is too weird.
Yeah.
So I don't know, possibly.
Yeah, and for a lot of people, having to write recursive functions instead of for loops or while loops, that is quite mind-bending.
Yeah.
So Elm is a wonderful entry drug.
I know that that's often in tutorials on functional programming. The recursive function is often the first thing.
One of the first things,
And I had trouble with that. And also it gives you the impression that you're going to be writing a lot of recursive functions. But then eventually, and correct me if I'm wrong, I felt like, the recursion is actually built into
a lot of the functors,
a lot of the things like map and all those things. So maybe it's not the first thing that you want to show people, because I think it gives people the wrong impression and drives them away.
Right.
You can show them a fold, and then you could go write your own fold with recursion,
but not right away. Just say, here's a tool that you use, the fold. But later on,
even earlier, starting even earlier, just the list map. I mean, the list map is now in every language.
Yeah,
pretty much.
Yeah,
right. A language that doesn't have this is it's rare nowadays.
Yeah, right. Exactly. Show them how to use the higher level tools, and then in a later
Peel back
chapter
the covers to
say, hey,
and recursion.
let's see how this works and why it works and everything. But I've seen so many tutorials that go, recursion. Let's get
Isn't it exciting?
Isn't it exciting? And then tail recursion optimization, you need to understand that at this point. And then I feel like, you've lost 90% of your...
Right, exactly. That's the thing. That's also the thing about Haskell. Haskell is very front-loaded in teaching because it's coming from this academic background, from this background of having joy in exploring these models. Mm-hmm. But most of the people out there, and including me, they really didn't want to explore these models. They want to do something. They want to change the world and build something.
Right.
And so you have to show them, like, where are the baby steps? Where are the first rungs of the ladder to building something that the world cares about?
Yes. Actually, that kind of segues into our onboarding experience with OCaml.
Oh, yes. Always very, very interested in hearing that because my colleague is spending a lot of time writing better tutorials. There's still a lot to do.
We followed the, just the installation instructions. And as usual, James refused to just take a curl command and
that's same.
Again, so we had to switch to Nix so that he could create this environment that he knew would just vanish and not mess around with any of his regular environment.
And it all worked great.
And it worked.
Yeah, surprisingly, it's not always
support. Don't always know if that's going to work with Nix. But so we were safe. But then the next page was your first day with OCaml, which sounded a little intimidating, but
I can tell you a funny story about this.
Yeah.
Originally, this was named Your First Hour with OCaml, and it was not shorter.
Not short enough to do.
It was not shorter than this.
Okay,
it was still a day's worth of work.
Understandable. That wasn't too big of a hurdle, to be honest. But then we almost immediately ran into, well, what was it? Oh, I know. Speaking of recursion, that was actually one of the original examples in your first day with OCaml.
Was it Fibonacci or was it something else?
It was.
No, it wasn't.
I think it was Fibonacci.
Was it the Fibonacci?
Yeah, it was a Fibonacci generator. And there was a keyword that wasn't explained that we guessed at, which was REC.
Let rec.
Yes, I see.
Yeah, and it was like, so I had to guess, but we asked
ChatGPT for a lot of explanation.
Yeah, we started asking Chat for things. We came up with the idea that just like their language, what do they call them that plug into your editor? Language.
Oh, LSP.
Yeah, language
server protocol.
Language server protocol. There should be the equivalent for programming languages. You should be able to have your own dedicated. Machine learning.
Your own ChatGPT for that language.
Yeah.
Right. Exactly. That would plug into your.
That will be a game changer.
Yes, well, it will be. I'm sure that
it'll happen.
Sure.
Will be
absolutely.
So, let's talk about OCaml, the language. Mm-hmm. One of the things that we are curious about is what's the big selling point or big differentiator with OCaml that's in the realm of not academia, but usefulness to programmers?
Well, in a sense, OCaml is positioned in a quite interesting position. It has a type system that is simpler than TypeScript. And nowadays, a lot of people are putting up with TypeScript in order to be able to write huge web applications, to write huge server-side applications with Node.js and TypeScript, or with Dino and TypeScript eventually. And TypeScript had to make some sacrifices in terms of its type system to wrap JavaScript.
Yeah.
Correctly.
There's some real constraints there on what they could do.
Yes. So learning TypeScript is actually, and learning to use TypeScript in a properly safe way, it's actually a non-trivial endeavor. And there's a lot of people teaching it, which is good because I still think this is a much better way to work with bigger systems than just using JavaScript.
Yeah.
And it's also much better than most of the other alternatives.
Yeah.
And OCaml is in a better position in this regard because it's coming from this Hindley-Milner type lambda calculus systems where you have a type system that has been built in from the start and where the language has been designed to find a compromise between what the language does and how you can express that in the type system. So there's a much lower learning curve for OCaml's type system, I would argue.
Yeah.
Because there's not so many special cases because of the compromises.
Right. There's not so many special cases because of the compromises, not so many oddities that you have to do, or not so many features that they had to retroactively add in order, for example, to get exhaustive pattern matching, to make the compiler check that you're really checking for every single case that your data can have.
Yeah. So one of the big selling points is a very powerful type system that is learnable easily.
Yes, I would argue so. I mean, there needs to be good teaching materials. So that's the thing.
Yeah.
Luckily,
in our explorations,
books.
did we have to explicitly set any types? I don't think we did. I think everything was inferred.
I think that's one of the things about ML languages is that they
not necessarily. Not all of them
really?
have this powerful type inference. So there's ML languages where you really have to annotate a lot. So you have to do it like the Rust way. Write the function signatures, write the type signatures on these. But in OCaml, they went for a design decision in the language to try and do as much type of inference as they can so that you don't have to annotate so much.
But are there special cases that you're still forced to annotate?
Yes, there are cases where you should do that. And there are cases where you get really not so nice error messages when you don't. So when you learn OCaml, it's a lot about seeing, okay, how much type annotations do I need? Or when does a type annotation help me when debugging? Or when is it so obvious that I just omit it because the code is shorter, more readable?
Yeah.
So is that, just a little aside, is that something that can be proven one way or another that, no matter how sophisticated your type system, there will always be special cases where you're forced to tell the compiler what this type is?
Well, there is something called decidability. So some type systems are undecidable, and Haskell for sure has an undecidable type system. With OCaml, I'm not even sure at the moment, and it's not the part I care about a lot.
Sure. Okay.
So I just care.
You're done with the theory stuff at this point.
Right. I'm kind of
But for practical uses, OCaml has a mathematically based type system that should be easy to learn and provides really strong type inference.
Right, and it provides really strong guarantees. So unlike TypeScript, it doesn't have any or unknowns or such. So you have everything typed.
That was actually one thing we explored was, okay, if I create a list that contains a string and an int, is it going to up-level this type to some common thing that is string and int?
No,
and
not
OCaml
unless
is like,
you tell
nope.
it.
It's just like, compiler, you can't do that.
Right. You can do it, but you have to use some feature from the type system to do it.
Yeah.
Okay.
You have to create your own type.
You have to create your own type that has these different
models. Would that be a product type? Would you have a product type?
You could do this as a product type, or depending on how you use it, you could also do this as a GADT, which is something kind of magical. So, but not that magical. It's like, so ADT. This is the product type or the sum type, where you have different cases, different variants, how the data looks. And GADT is something more general than that. It looks similar, but it's more general than that.
Yeah.
And this goes in the direction of existential types, where you can actually hide a type parameter within another type to make it look like it's just one type.
Yeah.
So this is quite magical.
Yeah.
But you don't need it. So the Go people have proven that you don't need this. They are dealing on a much more concrete level.
Yeah.
And in OCaml, you can work basically at the level of Go very well. You can write fine code at the level of what Go's type system does, just that OCaml does it better in a sense. So Go is very weak with some types, with these unions. I feel like they really have to patch this up, and they really have to fix this and bring this missing feature into the language, and then it's a fine language.
Yeah. I do appreciate languages when you can start with very familiar kind of basic type system usage, but then as you want more power, you can reach for it to existential types or phantom types or all the other kind of powerful type system things. And yeah, I think with Go, my experience is like, oh, I really wish I had this feature, this other kind of type system feature at some point, and it's just not there. And so I'm glad that OCaml and Scala and others kind of have these more advanced type system features that when you need them, you can at least get them.
Same. That's how I feel about Go.
Yeah. So, any other things about OCaml that are kind of in that value proposition area of like why developers should be interested in OCaml?
Well, it's a compiled language. It has a bytecode compiler that produces bytecode that can be interpreted on different platforms. So it's portable in that sense. It has also multiple native backends. So the only thing that I would say in terms of platform support that's not great yet is Windows, but it's getting there. So work is being done on that.
Nice.
And it has a pretty fast compiler. So people are always surprised how fast OCaml compiles when they are coming from, say, Rust or Haskell or C++ or such.
Yeah.
Oh yeah, we noticed it seemed to be extremely fast.
Yeah, but I've always thought that, if you do all this advanced type system stuff and you do all this amazing type inference, that your compiler had to be slow. But OCaml is kind of showing that no, that's not the case. Like, how does it that OCaml has been able to do all the amazing type system stuff without the slow compiler?
Well, it doesn't do all the amazing type system stuff like Haskell does. So it doesn't do higher kind of types.
Okay.
It just doesn't do a lot of things that become hard to check.
Okay.
And that's what put it in an interesting position, that it's in between. So it's in no place. It's the language that excels or that really pushes the boundary in a huge way. It's just the language that sits in kind of a sweet spot in the trade-offs that you have to make between like compile time speed versus more powerful type features in the trade-off between runtime speed and, I don't know, more something.
So you wouldn't pitch OCaml as having the most advanced type system ever.
No. Actually, I would anti-pitch it, because when you are tired of the most expansive type system, then you're the person who would enjoy OCaml. So when you have done Rust and you've seen like, oh, I love Rust, it's so fast, it's wonderful, but you have to do all these types. You have to write all these types, all these clones, all these lifetimes, and it can be really distracting. So for some projects, it's really worth it. You need to squeeze out the performance. You cannot afford a garbage collector. Then do Rust. That's wonderful. But when you're doing something like web development, where it's mostly I/O bound, where you're waiting on the database, where you're waiting on the HTTP request, where you're doing all this kind of waiting, there is really no point to carry the burden of having to write all these types. Instead, you're in a situation where you're developing something that you want people to use. And people, they give feedback. And they are really, really happy when you react to that feedback and when you can make a quick change, when you don't have to like rearrange and refactor your types. And do all these things that you have to do in order to do a full refactor on a language with a very powerful type system.
Yeah. So there are some kind of extensions, is maybe not the right way to say it, of OCaml that I've come across that I'd like to learn more about, which is I've seen the ReasonML stuff and Coq, and what's the orientation between those and OCaml?
Okay, so Coq is an automated theorem prover. So it's basically a similar thing as Isabelle Hall, where you write proofs and you perform these proofs by applying logic rules or having the tool apply logic rules to the point where it doesn't know what to do.
And you're talking about just any mathematical proof. You're not talking about something constrained to computer science, or what are the constraints?
Both. So with Coq, you can do any mathematical proof, but you can also prove properties about programs, which is a thing that's very popular to do in highly safety critical industries. Like automotive, medical, these kinds of industries where you have to have your product certified. You can write code in Coq, and you can write proofs in Coq, and then you can generate OCaml code, for example, and run that. And this OCaml code is proven to obey the specification you wrote in Coq. So basically, this is a much more stringent way of writing tests. You could imagine it like that. So when you write a test, you're testing some inputs and some outputs. Whereas with formal verification, you're making a proof over all inputs and all the outputs. So the coverage is just on a different level when you do formal verification. But this is something that only affects the people who work in these industries, and these jobs are fairly rare.
Yeah.
So ReasonML, that's something that's much closer to, I think, what the majority of us have to deal with and want to deal with. And that I don't really know the history of all of this very well. But in short, there's an alternative syntax for OCaml. So at some point, a community broke off from OCaml to say that, well, we disagree with OCaml's syntax. We don't like that it's so alien to the average programmer. We don't like that the JavaScript developer can't just take it and write code and we can show them and they are familiar. Instead, people get this kind of angsty reaction, seeing like, oh, this syntax, it looks unfamiliar. I'm a bit worried. Can I read this? Can I understand this? And this is what ReasonML. So, or the reason
trying
syntax,
to bring a more familiar syntax to it.
Yes.
How much of the OCaml foundational toolchain compiler, all that kind of stuff, is shared to Coq and ReasonML? Is there a common foundation, or are these kind of separate worlds, or how does that work?
So as I understand, ReasonML makes heavy use of the OCaml compiler. So they are very close, and we're sharing a lot in this regard. Coq, however, that's a different application. So it's just basically an OCaml application. So Coq is written in OCaml.
Got it. Okay. But a different syntax, different compiler. And then, as you said, you can take Coq and do some transpilation or something down to OCaml, but essentially a different.
Yeah, so Coq is actually a very rich academic ecosystem, and academic and used in highly safety critical industries. So, for example, there was the CompCert project to certify a small C compiler to prove that it compiles the code correctly to assembly code through multiple layers of intermediate representation. So that's pretty impressive projects. But a lot of this formal verification is not quite so ergonomic that you could do this at scale, or that you would find people easily who can do this at scale. So you can teach people, but it's slower than writing just the program. When you have to write the program and prove the correctness, or when you have to express the program in this other language, then prove the correctness over that, generate code.
But so ReasonML is a prover as well?
No, ReasonML is not a prover. So ReasonML is just like an alternative syntax to OCaml. And it comes with a community that is very practical minded. So lots of great things have come to the OCaml ecosystem thanks to the Reason community, who were very interested in like using React safely from OCaml. So there's a wonderful project, Reason React, that wraps React in OCaml so that you, or in Reason. So nowadays.
So ReasonML is kind of like OCaml with a more approachable syntax or more familiar syntax.
Yes, with more brackets, I think.
More brackets.
No,
I see. Well, I mean, so far from what I've heard, the most interesting, the thing that OCaml does that's kind of unique is proving correctness. And I can see, I mean, like, I don't know any other, system, at least I'm unaware of any other system that could do that. And so
with varying degrees of complexity. So it sounds like if you go all the way to cock, you can prove,
yes,
you can have proofs,
but it's a lot of work. But it seems like, I mean, could that be used for like security, validating the correctness of your security system or something like that?
Depends. I mean, usually security is in the plumbing, or security issues are in the plumbing, right? So, and the plumbing isn't usually the thing that you verify unless you first establish a verified platform that verifies all the plumbing through all the layers, which is in principle doable, but it's a giant project. Project, and very, very hard to do at an industrial scale. I mean, there's things out there, but I haven't been in the loop on that.
Okay.
But what I do see is like they have wonderful applications for this kind of verified software. For example, satellites in space. So you only get one chance to deploy into production. So you want to do it right.
Yeah.
And that's obviously a wonderful use case for a language that can be fully formally verified and has been exceptionally stable and backwards compatible over the last decades.
So it sounds like one of the kind of killer features of OCaml is the ability to in varying degrees prove the correctness of programs, and going all the way to cock if you want to go to the extreme end of that. But even just base OCaml gives you the ability to prove correctness in a good way.
Well, I think
that as like one of the killer features, or
it is one of the killer features, but the use cases are not a lot. So we really want to have more killer features of OCaml, and I think web is a pretty good one. Like OCaml has a wonderful GraphQL library. Like, I don't know, have you used GraphQL in Angular?
Yes and no. Like I like some of the ideas of it, but yeah, I think generally the times I've used it felt like a struggle. So maybe if OCaml can make GraphQL not feel like a struggle, that would be nice.
So actually, OCaml is the first language where I felt that GraphQL was not a struggle, because it had a good library, and it has a good library that makes use of the type system in such a way that you can declare the schema in such a way that you're actually forced to obey the schema. And when you obey the schema, that's pretty nice. So you know at compile time that you obey the schema. Nice. So not at runtime when something crashes and unexpected stuff happens, but at compile time. And there's a pretty nice blog post series. There's a wonderful blog post series. I keep shilling that one because I really like to read it again, because it also shows like the feature GADTs. So how you can use GADTs to model these GraphQL schemas. And at the point where you have a verified or a correct GraphQL schema, then you can use the code generation technology from the TypeScript ecosystem to generate typed bindings for your TypeScript code, and you connect to all the existing ecosystem that people already use.
That's cool. That does sound like maybe one of the other potential killer features is kind of correctness with GraphQL.
Yeah, or correctness with mostly anything, like correctness in database access. So there's still room to explore. But when I compare what I used in Rust for database access, for type safe database access, well, it wasn't really fully type safe because it's kind of hard to get this right in terms of ergonomics, like these kind of database wrappers, these schema, these SQL builders.
Yeah.
I'm pretty sure no one wants an ORM anymore these days.
I think mostly it's been kind of shown to be not too restrictive. Like not everything maps to objects.
Right, exactly. And that's not what you do in OCaml in general. So you don't deal with objects, you deal with values, and you deal with functions operating on them. So it's a much simpler way of thinking. Instead of thinking about an object that has methods on it, you just have data. And like in C, you just have data. This is what I like about C. Only having data.
Yeah.
Well, and I think taking inheritance out of the picture, like Go and Rust, I think OCaml. Does OCaml have inheritance?
No, OCaml doesn't do inheritance. So OCaml markets itself as the rehabilitation clinic for the OOP program.
Right, exactly. No, I find that taking inheritance out of the picture seems obvious in hindsight.
But it was kind of looking cool back then, right?
Oh, yeah, at first it was like, but we didn't understand what the limitations were, what the trade-offs were, and like also I think because of Smalltalk, where they just everything was inheritance and adding methods to these things, which is like, how does that balance with the Liskov substitution principle? It doesn't. We didn't really get all that. At first, it was just all shiny and, oh, look, you can do everything like in Smalltalk. But with the constraints that we had, you couldn't. It wasn't Smalltalk.
Well, and I think it took us a while to realize that,
it took us
that we can adequately model what we need with sum types and product types.
And if you, and instead of inheritance, you use composition. And that works perfectly well. I want to ask a really basic question, because when we were going through the onboarding, we immediately came across the double semicolon. And the one thing that it said was, you have to put this in here. It's essential. But there was no description of what does it mean.
Right.
And we couldn't find it.
Yes. So I think this will most likely be resolved when we push the work in progress tutorial live. But this is an idiosyncrasy of the REPL. So of UTOP or of the OCaml REPL, where you write an expression and where you have to tell it where the expression ends. So it's basically just like in Postgres, you also have to end with a semicolon. And it's the same thing.
You're just telling the REPL that I'm done with my expression.
I'm done with my expression. That's all it says.
Okay. But when you're in a source file in VS Code,
you don't do this.
You don't need it because
you don't do this.
Yeah, say that. Okay, well, that's helpful. But I would just like to, since it seems like you're working on some of this stuff, I would like to put in a request, which is don't use the REPL to show your examples. Use files that can, because one of the things about it is, like, I'm looking at the REPL code and I'm going, how are they testing that? Whereas if you have standalone files, if you're testing it by typing it in and checking it, then it's going to get out of sync.
Automated testing of the code that's
there's some work on testing this in an automated fashion.
Nice.
I think you're right. So what we want to do is we want to make these runnable. So we want to make these run in a little interpreter in the browser, so that you can click play and then it's giving you your response.
That's cool.
But this is there's no ETA for this. But that's the plan.
Nice.
Okay. How does OCaml work? Well, a little background. I'm fascinated with Rust, but only to the degree that I can make Python extensions with Rust, which is the first and only language I've been easily able to create Python. I've tried it in C and all that. It's always run into problems. Rust just works. So I don't want to write big Rust programs, or at least that's not where I am now, but as extensions to Python. So as what I saw in the OCaml docs is that it works well with C.
Yes, it does.
But I'm not so interested in working with C.
You're interested in Python interop.
That's the person who's more interested in working with C is the OCaml dev who wants to do heavy number crunching or wants to use libraries from the C ecosystem.
Right.
So yes, there's a big gap in terms of showing how to do the FFI with popular languages that are slower than OCaml. So for whom OCaml can be the faster one.
Or slower, or not as
safe.
Not as safe, exactly. So if I go, here's a piece of my program that I am worried about safety. Oh, okay, now that might compel me to say, all right, let's do that piece in OCaml. But what's the story for connecting? Is it just C? Is that just the way it is, or is there any kind of tooling to help me? Or
this is a good question. I don't know. So I've never tried to integrate with Python. So I think it's possible. So someone else has integrated with Rust, used Rust from Rust libraries in their OCaml application.
But there's in their OCaml. Oh, I see. They use Rust.
Yeah, but the other way around too. So between OCaml and Rust, there's interesting work ongoing to formalize both of their memory model boundary so they can interact safely. But this is not something that's very available yet.
So there's another thing that I came across in the documentation, which is, this is a little bit of a hobby horse of mine, something that has gotten into the general programming world is the use of the term variable to mean anything. And
yes, it means anything.
Yeah, I mean, sure. Oh, no, it's a variable that you can't change. Or something.
An immutable variable.
Yes, it's an immutable variable. And it's like, that just drives me crazy because those words are diametrically opposed. And I have noticed the use and it's confusing when you're looking into it and they say, and you use this variable and this variable. And my question is it variable or is it immutable? So
no, in fact, it's immutable unless it's a reference to the heap,
unless
a mutable reference. Unless it's a mutable reference
okay.
to some kind of structure on the heap.
And so you say mute or something to make that
ref. So you can do let x equals ref 0 to get a reference that points at an integer that you can modify at runtime.
I prefer Rust's mute to ref, because ref just tells me, oh, this is a reference to that. It doesn't tell me anything about the mutability of it. So
but the mute is on the type. So here the ref is the value. So it's part of the expression.
But your type actually then becomes mute of int or something, or
it doesn't. So I think it's also named ref or something.
Okay.
I didn't do a lot of the mutable stuff.
Right.
So I'm actually in some regards I'm very much an OCaml newbie because OCaml has all these different features that you don't have to use. So you can do very well with a very small subset of OCaml. So kind of like Elm plus.
Yeah.
So
that would be the tutorial that I would want to see is, what is this subset that you can do very well in?
Oh, and maybe specifically, like you're mentioning, Elm is another possible value of OCaml is look at using OCaml to build a web application or something like that in a way that you would maybe do with Elm, but doing with OCaml in some subset of all the power. Be interesting.
Yeah, that could be compelling.
I did want to highlight the features of OCaml as we were learning about it. that I thought were great. Yeah, I think when we were going through learning OCaml, we're like, okay, great. It has product in some types. It has type inference. It has exhaustive pattern matching. We dug into a bit the concurrency and parallelism. We're like, yes, this, being able to do joins on threads and tasks.
Yes, this
The
is brand
libraries
new.
around this. Yeah, and it all looked good. I think, looking at it, it's like, okay, it has like all the modern language features that I would hope every language has today. The one feature that we were like, was exceptions. And I'm curious
Oh
your
yeah.
perspective on it. Like,
Well,
is that just a legacy thing that like people don't use anymore, or what's the story on
so
exceptions?
clear. It depends. Very clear. It depends, because I mean, with exceptions, it's like you have to cover your bases. You really have to be a nice person, because when you write a library that throws exceptions, you have better written, very good documentation. But instead, I would prefer if you would return result types.
Yeah,
So you
exactly.
can do exceptions within your library because they're fast. So they are just faster than threading around all the results and everything,
Yeah.
because it's interrupt and like handler and stuff like that.
Yeah.
So it's just naturally faster, and for that it's fine. And you can use them responsibly. And in some places, it's actually quite convenient. So when you are writing a web application, in Rust, you have to thread your error types all the way through.
Mm-hmm.
On the positive side, Rust gives you a lot of power here. It has the question mark operator to automatically try to convert the error types using the trait that you provide.
Mm-hmm.
So it's pretty fine. But OCaml doesn't have this kind of error operator, and instead comes from a legacy of having these exceptions instead. Yeah. And now it has even expanded on exceptions by adding effect handlers, which is like a more general thing that allows you to do this kind of resumable computation, this resumable stack switching computation.
So is there a way to guarantee that you handle all possible exceptions?
Unfortunately not. And that's why I strongly recommend any library author to use the result type instead, because then it's part of the function signature and your user will be happy and thankful that you did.
Right.
Because then your type system, it's part of your type system.
It's part of your type system. I really like that Rust doesn't have exceptions and more or less forces you to use the result type.
So in the world of OCaml, maybe the exceptions are in a place similar to mutability. It's like if you need this for some reason, do it in your little constrained world, but don't expose it to your caller. And I think that exceptions and mutability maybe are in that same boat of like, sure, you can use these more powerful, maybe when you need some performance benefit or something, but don't expose that to your caller.
Yeah, sandbox everything inside. I think that may be a general principle. I mean, I feel like I encountered that in the Red Book, where they were saying,
this is the Scholar Red Book.
Oh, sorry.
Red Book.
Where they were saying, okay, so here's how recursion works. And then at the lowest level, but hidden from everybody, there's mutability that's happening. And you're going, what? Mutability? That's not okay. And then you see this principle. It's like mutability, which is a thing that is not scalable. So you keep it at a controllable scale.
Mm-hmm.
And then it's a fine technique. But your end user doesn't know anything about that's happening. So they can still live in this immutable world.
Right. Mm-hmm. Right. Yes, this is a very, very common philosophy in OCaml land as well. So I think this is something that all these more functional languages, the ones that care about you writing correct code, using immutability to your advantage, like using side effect freedom to your advantage, would recommend. But OCaml is a very permissive language. So it lets you shoot yourself in the foot. So it's not like Haskell that puts this kind of power suit around you that makes it kind of awkward to move at first until you figure out how to operate this. OCaml is more approachable in this sense. So if you've used an imperative language, you know that, okay, when I declare a variable, so when I bind an expression to a name, then it gets evaluated. So in Haskell, it wouldn't. So it would get evaluated anytime later, whenever necessary, whenever it's
I
convenient for
definitely
the
appreciated
compiler.
OCaml's strict evaluation. Is that the right word for it? Strict evaluation, not lazy
Yeah.
evaluation, as the default. But then there is a way to do lazy when you want it in OCaml, and for me, that's the right direction. Is make strict the default, lazy if you need it.
Is there a version of OCaml that runs on the JVM, or is that even possible?
That's a common question, and I don't. Well, no, I'm mixing this up with LLVM.
Right.
So on on LLVM it's difficult because you have the garbage collector. So in LLVM is not good with garbage, but on the LLVM, on the JVM, I don't know. So there's JS of OCaml to compile to JavaScript. There's Melange who compiles OCaml or Reason syntax to JavaScript again. But to Java,
do you know if there's been any OCaml to WASM GC?
There's work being done on this.
Nice. That's exciting.
There's very promising work going on.
Cool.
Because
the kind of PhD student thing.
Yeah.
That seems like that could be a gateway to interoperability.
Yeah.
Yes, so we have high hopes in WebAssembly because it's just a natural way to do things. And because WebAssembly would unlock writing frameworks like doing something like Svelte, but in OCaml, fully type safe instead of with types patched on and with gaps in the type safety. Because I like Svelte. So I really like that it's short. So short, it's readable. So you write HTML, you write your templates as you're used to. Don't do any funny syntax things. And now if you had a similar thing in OCaml, that would be quite nice.
That would be quite nice. I like that. In the concurrency world, we played with some of the concurrency stuff and it was good. I didn't get a chance to dive into the kind of IO libraries, but I did like the idea that you could use EIO for kind of the algebraic effects, or you could use, I forget the other one,
LWT,
for monadic based effects. And I was like, cool, I want to try them both. But what's your take on EIO and the kind of algebraic effect style or direct style of effects?
Well, what I can see is that, EIO is the new kid on the block. So there is EIO adoption being pushed to see, like, is this the thing that the community will do? Is this the thing that will see adoption? Or where is this going? I've used EIO once just to write a little example program, more or less, like just translate someone's Go program from Twitter. So I don't know, this Dex guy, so the one who sometimes asks really, really good questions. And I translated the question about like running multiple async threads, awaiting them in the most concurrent way.
And
really?
I'm sure I mean, you got to set up channels and do your Go routine.
No, it wasn't so bad.
No,
actually.
It wasn't so bad in Go?
It wasn't so bad, but the OCaml code was not worse than the Go code, so that was actually pretty fine, I think. But I don't do a lot of his concurrency. So on the OCaml org website, we still use LWT because all our libraries use LWT. And when they migrate to EIO, we will use EIO.
Is there algebraic effects? Like, there's not algebraic effects actually in OCaml's language, but somehow EIO was able to create algebraic effects.
There are algebraic effects in OCaml's language now. So same patch that landed multicore also added these effects. But for now, they are untyped. So work on a type system for that is still open research, like finding a good balance between expressiveness and what you have to write in order to type check this.
So I assume on the site that you manage about OCaml, you probably have a list of companies that use it.
Yeah, well, we have a job listing board on
and a job
OCaml.org
listing
where you
board.
can see quite a few companies who may be hiring, but it depends. Some of these companies are of the sort of like, okay, we have a listing just so that we can snatch up promising candidates as they come to us.
Well, so what is if a company is using OCaml, do they find that they need to take, some other programmer and train them into
Are they hiring Haskell programmers
or is that or
Jane Street for sure has to, because they are very large. So Jane Street, as I am told, has around 900 or more OCaml programmers. So they do have a certain churn and a need for OCaml programmers, and they do extensive in-house training to get them up to speed, also up to speed with their own internal, very advanced processes, which are partially aligning now with the broader ecosystem as tooling improvements are made. So for smaller companies, I don't know.
They just hire people away from
They
Jane
just
Street.
hire people who are around. So they hire people who already know OCaml most likely, because they don't have this intense pipeline. But Taridas, they do hire both. So I was one of the no OCaml people. So, but Haskell is really a keyword that gets you somewhere. So if you can write template Haskell, you're already in a good position to be hired by these kind of companies that do OCaml, F# or Scala or such, because you've kind of demonstrated, okay, you managed to breach the Haskell adoption barrier.
Yeah. So the career path for people that are into Haskell is OCaml or Rust at this point.
Oh yeah, Rust is nice.
Yeah.
Oh yeah, I'm enjoying it.
Have we missed anything? I feel like we've kind of covered your journey, the OCaml language, a little bit about the features, the exciting things. Anything on the future of OCaml that's worth highlighting? What's
on
coming?
On the future of OCaml? Well, what's coming? I mean, we really have to get this ecosystem more complete. So the future, it depends a lot on what we do, I guess.
Yeah. You're creating the future right now.
Right. We're creating the future, and we're having to make these kind of decisions. Like for me, the personal decision would be to, okay, do I stay more like behind the scenes, or do I go down the road of like becoming more of the community manager of OCaml, like organizing things or like encouraging and bringing people together to build the kind of projects and the kind of frameworks and libraries that people need in order to have a happy experience with OCaml.
Mm-hmm. Yeah, it's a good question of like so, you're in a position where you can invest your time to grow OCaml, and where should you put that investment?
Yes, exactly.
That's kind of a fun place to be. Exactly. Is it in documentation? Is it in tooling? Is it in libraries? Is it in, there's all these different parts of the ecosystem that you could invest into, and
so the great part is
the most impact.
Right. The great part is that it's not me alone making these kinds of decisions. So, but they really need, so OCaml really just needs people to come together and have fun.
Well, it sounds like you just answered your question.
Yeah.
Bringing people together. Yeah. Nice.
Cool.
Well, yeah. Anything else?
No, I don't know. So that was really cool.
I will continue my explorations with OCaml. I have a little obstacle course for concurrency called Easy Racer, and I do want to try to build the OCaml version of Easy Racer.
It's a pretty good
So maybe you and I could work together on that.
Oh yeah,
that sounds cool. So are you doing this publicly somewhere?
Oh yeah.
Yep. Yeah, it's on my GitHub. We've got implementations in Scala, Rust, Go, TypeScript,
Oh, that's great.
Kotlin, Java, got all sorts of different Python.
We did a Python one.
We did get a Python working. I'll send it to you, and maybe we can work together on the OCaml
Do send
one.
it to me. I'm very interested in this.
Because then you can compare. Well, and also it shows you, does a language library system support even this particular approach? And also it's been good because it's created sort of a list of here's the kinds of things that you probably are going to need if you're building something with concurrency.
Yeah.
So
it sounds like a great reference too.
It is.
Like when you know how to do this in Go, for example, then you can see, oh, okay, so that's the Go code, and now this is the corresponding OCaml. That helps a lot, I think. So specifically for people who learn by doing and by seeing, by imitating, instead of by reading the manual.
Right.
And I like these people because they're just busy building stuff.
Yeah,
so it's
that's for me. I gotta write some code to actually understand it.
Yeah, that's true.
Awesome. Well, Sabine, thanks for joining us, and thanks for all your work on building the OCaml community and making it awesome.
Well, thanks for having me, and I hope you will have a lot of fun, whatever you do next, and I will check out your repository. This is looking so exciting.
Awesome.
Great. All right.
Thanks.
Bye.